right now
Yeah. Hello. Good afternoon. Yeah. So my name is Anurag. Just a quick intro. Co-founder of Avail. Avail is a new data availability focused L1 blockchain that focuses on enabling rollups on top. This is a project that was initiated within Polygon in late 2020, and I'm one of the. I originally co-founded Polygon or Hunting Network back in 2017, and we spun out the project in March earlier this year, and so we are now a separate entity. So I just today's session will just go over what is Avail in general, the architecture, what use cases are we targeting, and in general bit about the use cases as well. This is the rough agenda. So I just want to set the context for this talk. In the last 2-3 years, what has happened is rollups have basically taken center stage as the way to do execution. So before rollups, there used to be this whole alt L1 sort of paradigm for scaling execution. But once rollups have been proved to work, these have taken center stage over the last 2-3 years, and they are recognized as the main way to do off-chain computation. And while today's rollup focus on scaling execution, what they really rely on is this very scalable base layer. So Ethereum in general began as a very execution-focused blockchain, right? Like it didn't have data availability in mind for rollups later, and so of course Ethereum has been pivoting its roadmap to be more rollup friendly or data availability focused. It's a production blockchain with billions of dollars of assets in production, so it's going to take some time. So you must have heard of things like proto-dank sharding, and such, but those are those will take some time. Proto-dank sharding is supposed to be sometime next year, but dank sharding is going to take at least 3 to 5 years, is what we feel. And so rollups cannot be really waiting for around for that kind of scalability, and so that's why that's the basis for Avail essentially. That rollups are hungry for data availability, and Avail provides a very scalable data availability layer. And I'm just going to begin with this thesis that what we really believe is that every important base layer blockchain is really just going to end up as a tier layer, right? Because execution is more or less being pushed onto rollups on the layer 2. Right? Like so, that's the whole positioning behind Avail. And what it really is. I'll get into the architecture a bit, but essentially it provides raw block space for rollup chains. So it provides consensus and ordering to rollups, right? Like so, there are two parts to the rollup story. So rollups handle execution on top, but they really need ordering and a consensus service at the backend, and that's what Ethereum does for rollups today. So rollups really take in some transactions, sequence them, and then push them to the Ethereum base layer for ordering finality, for example. And of course, they also push other items like proofs, for example, so that you can have a validating bridge to Ethereum for Ethereum assets and so on, for example. But the base layer is the main consensus and ordering piece. And today, so again, I'm not getting too much into what Ethereum does, but like Avail, for example, is that base layer which is focused on providing scalable data availability. And the main difference, the architecture is that Avail doesn't really have any execution. Like it has a minimal execution runtime, but doesn't have smart contracts. So it basically separates that function so that we can scale data separately. And that's why we are able to, of course, support execution environments of any kind. So EVM, Fairplay, but also newer VMs, Move, whatever. I mean, because we don't do any execution at the base layer. And we also implement a very novel construction called data availability sampling. This is our approach is based on KZG polynomial commitments, so and validity proofs. So the closest project that you could track with us is Celestia, which does a more Merkle hash and fraud-proof based approach. What we do is more similar to what Danksharding, the roadmap intends to do. Use a combination of KZG polynomial commitments of the data and validity proofs rather than fraud proofs to do the data availability sampling. This, of course, allows very light clients to sample the block pretty efficiently. And we expect that there will be like millions of light clients that will be run through this. And of course, we can enable like all kinds of rollups, and as well as including something in the short term that we are focusing on, something called validiums and optimiums, or even L3 chains. Essentially, this is the architecture. So we have rollups submit data to the block. So there is this original data. We erasure code the data, which then we kind of extend the data using KZG polynomial commitments, and then we put the commitments into the header. Then we kind of propagate it to all the validators in the ecosystem, and then finally the block is created. Happy to answer more questions on this later. But this is the rough. So we have this concept of application ID, and each application ID corresponds to a rollup, for example, and so you can actually put different rollups can put data into the same block and be differentiated by application ID. And because we use KZG polynomial commitments, we are able to ensure that the commitment of the eraser coded data is the same as the eraser coding of the commitment, for example. And the beauty of this is we can actually increase the matrix size as well. So this is the rough layout of the matrix. So we construct like an M cross N matrix. Erasure coded to it becomes a 2M cross N matrix, and we can create a commitment for each row. And because KZGs are homomorphic in nature, so this C1 to Cn can then basically be extended to C n minus plus 1 to C2n, for example. Again, we'll get into this in much more detail later. So there is this validator network which we use consensus. We use the substrate node from the Polkadot ecosystem for constructing the validator node, and so we use Grandpa and Babe consensus for this. This is like a hybrid ledger consensus where Babe takes care of block production and Grandpa does eventual finality. Kind of similar to Gasper, but I'm not getting into the details, but essentially it's a VRF based data selection and mechanism. The main difference here is the finality is on chains, not on the blocks. So we do like a series of chains, for example. So this is pretty robust, and we can support up to 1,000 validator set for now. With the introduction of BLS in our system, we can actually go up to 10k validators or more as well. But we start with 1,000 validators. There is also a unique nominated proof of stake, which is very different from delegated proof of stake. So internally we use the Polkadot SDK essentially uses something called fragment, which essentially ensures that stake from nominations, it's called nomination instead of delegation, it flows to a nomination pool, like a pool of validators rather than to a single validator. So essentially there is in protocol logic to ensure that any delegation or nomination in this case moves throughout the system, is kind of evenly spread throughout the system, so that you have you don't get into stake centralization sort of issues. And we took a conscious decision because of this, because before at Polygon we used Tendermint in our Polygon POS system, and there were very large stake centralization issues because top 7 or 8 validators used to control 67% of the stake. So this is very, very useful from that context. And the second component in our network is the light client. Essentially, this is like an independent node that kind of randomly samples data of the initially with the full node, but we've been working over the last couple of years to build out this whole P2P. So the light client network is a P2P network in itself. So the first light client bootstraps of a full node, but the other light clients then can bootstrap off a peer light client. They don't really need access to a full node in itself, for example. And so you have this almost, like it's not technically equivalent, but almost torrent-like structure where a new light client enters the network and they just start bootstrapping off the light client network in itself. We also implement Kademlia distributed hash table implementation on the light client, which enables this overlay P2P network. And so this is actually one of the
So you're using the P2P. How are you doing it?
Yeah. So we basically started with implementation of the IPFS lib P2P, but then we chucked that out. Then we went to the low level, like Kademlia implementation of the P2P for this. And so we actually built out a lot of work on this. But yes, it's based on the Kademlia lib P2P crate. And we also gave a presentation of this at Kademlia Con during SBC. But happy to chat more on that. And the idea with the light client is that with only a few hundred, LCs, we are able to kind of, the entire blocks get verified pretty quickly. And so the more the light clients we have, the quickly the verification can be done. And the main thing is that you don't really need to trust the validator set after the blocks have been finalized. The validator set is only for the initial block finalization. After that, once you have the light client, you can actually, it's very light, you can embed the light client into sequencers and such, and you can actually, you don't need to rely on any honest majority. It's basically, it's a honest minority assumption. Once enough LCs have sampled, data also remains available on the DSC.
Do you guys consider like more browsers only for light clients?
Yes. We actually have, I don't have it on this PDF, but we have a browser light client that we are releasing soon.
I'll talk to you after.
Yeah. Again, importance is that you don't need to rely on centralized RPC. You just run your light client. You can actually use those RPCs in general. And the interesting thing is we are now starting to integrate with wallets who can run this light client, like embed this light client within the wallet, so that what we believe is data already sampling light clients will increasingly be on the wallet side. And because ZKP's systems are also improving, we are also actually doing a POC for embedding a ZKP proof verifier in the wallet as well. This is some performance metric. Actually, this is a little dated. In our latest release, we have had about 70% improvement. But just to illustrate that the block size increase for our blocks, so we have benchmarked up to 128 MB blocks. We start off with a very modest 2 MB kind of configuration, but you can see that the performance is pretty good even in case of 128 MB blocks, and our block time is set to be 20 seconds for the DLA. So we are very comfortable in even doing 128 MB blocks. 128 blocks is like too much. We don't really need those at the moment. But we have actually increased performance here by up to 70%. So this is like more in the range of 2 to 3 seconds. And proof generation is like very very trivial. So this is all. So we do a very light circuit, and so for the KJPs, and so the verification is also pretty low. Okay, so quickly, in general, what can be built on top? Any kind of rollups. So of course, sovereign rollups, Validiums, Optimiums, app-specific chains. We actually have integrations for the OP stack ready for running Optimiums. We have Polygon ZK AVM, Validium ready. We are working with Madara from Starkware very closely to do L3 app chains. We are hoping to have the Arbitrum Nitro integration up and running pretty soon. and hopefully the ZK Sync one also should be out next year. We also work with newer sort of VMs as well, like Sovereign Labs with RIS0 for example, and so on. We also have built out a data attestation bridge. So this is like a special bridge from Avail to Ethereum. So initially we built that out as a optimistic construction, but now we've been working for the last 9 months or so with Succinct, which is the team which has built out the telepathy protocol for Ethereum, the Sync Committee protocol, and with them we have built out a Grandpa ZK light client bridge, which allows us to do a bidirectional bridge between Avail and Ethereum. And this can be deployed to any EVM compatible chain. So we plan to do this on all the major L2s as well. We're not getting into sovereign rollups too much. This is our development stage and timeline. So of course the project began way back in late 2020 within Polygon, but our second long-running testnet was finished in September, and we are now on our incentivized testnet, which we are onboarding around 300 validators for now. Mostly our tier 1 and tier 2 validators. We will scale it up to 1,000. And our rough target for mainnet is Q1 of 24 next year. Yeah, these are some of the optimizations that we do want to do. So, like currently, as I said, if you remember, we have these row level commitments, but we are trying to do KZG multi-proof, like a multi-proof opening for the entire row. So that, right now we have M cross N or 2M cross N cross N sort of a proof generation thing, but this we can bring down to like M complexity, because the multi-proofs just need to be created once. And as I said, we already are almost finishing up the ZK Snap based data addition bridge, which is a Grandpa ZK light client circuit. Yeah, I think that was just a quick rundown of the project. These are some important links. Yeah, I think that's it. Thank you.
Any challenges for unfortunately Sebastian and I'm the audience.
Avail also uses KCG commitments and data will be sampling the same.
Avail doesn't have data will be sampling.
It's coming up, it's not.
Yeah, it's a 2-year effort. We spent, we already did that. We know how. See, basically, yeah. I like Sriram a lot, but let's look at the basically, it doesn't have data will be sampling. Data will be sampling takes once you get into the weeds, it takes at least 2 years to build, because it's not reusing any infrastructure. You have to really build out the P2P infrastructure for that. And yeah, I don't see data sampling coming from another project within 2 years if they're starting now.
So yeah, I think they're doing proof of custody for data first, which works better with their attestation like validator set, since you cannot fork away from the layer 1 network.
Yeah.
So you cannot do sampling before choice to adjust where the data is and where it is not. But custody works. Now I wanted to ask a question about exactly that P2P thing you're talking about. So we have been talking about how live clients and how end users get access to the data. But I'm very curious on how rollups or operators publish data onto the network. Because if you compare this to the layer 1 design, the full text sharding, now what the challenge there is not so much the data availability sampling, that has been mostly solved from a sampling perspective, but the dissemination of the data to the network. When you have this many validators that all have to host data that these live clients are querying from, they all need access to, some form subset of the data that they are able to serve to these live clients. And and you have 6 large blocks and a low block time, or even just the 12-second block time on layer 1, it becomes a really difficult challenge to keep that decentralized. So how do you envision rollups publishing data to the Avail network?
So if I understand the question is how like rollups submit data to this increasing amount of data to the network.
Right.
What is the centralization
So
problem you are referring to?
the validators that the first hop, so the validators that are initially hosting the data before live clients
Yeah.
sample it,
Yeah.
how do they get access to the data?
So see the workflow. Okay, let me come on the workflow again, right? Like so, what we do is basically, so you submit data to, let's say, via the light line to an RPC, for example, to the full node or the validator node. The validator node basically, depending on the leader selection, takes in the data, constructs a block, provides it to the other validators. They come to consensus and finalize the block. So that's the first step. Basically, the light line will then take in the headers from the finalized block, and then start randomly sampling a full node. Once one light line starts randomly sampling the full node, it also stores the data, some of the data that it samples on the DHT on the light line.
Right.
The second light line that comes can initially query this light line, for example, and then if they find the data, then they can also store it there. But then otherwise, then they go to the full node. But once
Okay,
you
so
have
you
like
do not proactively disseminate the data to nodes on the DHT, but rather you wait for those nodes to query the data.
Yeah.
Okay.
Certainly, we require a set of LCs to be polling the full nodes for this, but the assumptions are that only a few tens or 100 light lines are really required to quickly randomly sample from a block. And the idea is that we expect that like with our work with wallets, for example, and so on, we should be able to have a few hundred or thousand light lines easily doing this over time. But essentially, with wallet integration, we expect that number to go much higher. So we are actually thinking of like a million light lines or so.
So more of the burden of publishing the data is with the builders or the creators of the data, and then publishing it to all those different nodes that can then further disseminate.
Absolutely.
Okay.
Of course, the validators also store this data because they are incentivized by the the native token like incentives, for example. So validators do it, of course, but full nodes and this new category of light lines and let's say roll-up sequencers who embed this light line also have an incentive to kind of store the data. Very similar to how let's say Ethereum full nodes do it. But this is like slightly different. Yeah.
It starts to become very difficult to disseminate it to lots of validators, like full nodes, that once you reach those numbers above 2 megabytes blocks, that's the one to keep the node
you're right, and we have been modeling, doing a lot of modeling on that in terms of how information can be disseminated. So happy to share more data afterwards.
I'm very curious. I've been arguing for layer 1 to adopt the discovery DHT, the DiskV5 thing they have, to publish the samples. So I very much agree with that design part of the Avail project. But then I think the publishing part is largely underestimated.
Yeah, we are not saying we have completely solved all the challenges, but we have done a fair bit of. There are still some issues with P2P. Like we still maintain like a whitelist, for example, for P2P because DDoS attacks and all that. But we have solutions.
Right, okay.
Any more questions?
Yeah. Can I actually know what about the main difference between the two solutions of the data availability sample between Avail and Celestia?
Yeah. Okay. So Celestia uses this Merkle hash based and fraud proof based technique. So essentially, when rollups, for example, send data to Celestia, so they will do the erasure coding, do the Merkle hash commitment, for example, and then the light lines have to do this fraud proof, play this fraud proof challenge game, right? So there's a period where you have to prove that the encoding was correct or not. So you can like if I have to dumb it down, it's kind of similar to how optimistic rollups and ZK rollups do. Like I mean it's not really the same, but the timing windows are different, for example. But they do a more optimistic kind of implementation. We do a more validity proof based kind of implementation. And the real result of that is, let's say if you're running a ZK rollup on let's say Celestia, for example. So let's assume that you've created the validity proof for your rollup, but you still need to wait for the fraud proof challenge window on Celestia to like finish before you can get DA guarantees. On Avail, because you have a validity proof, and we kind of create the proof these are the benchmarks, right? Like, so as soon as our blocks are finalized, you get DA guarantees as well. So it's primarily, it boils down to the developer experience bit. So Celestia started probably like 9 months before us, so we are a little behind in development, but like essentially, like it's a fraud proof, validity proof kind of an argument. But on a DA thing, it's just a performance thing.
If no more questions, we can
Why substrate? So
Yeah. Okay. Good question. So like before I was at Polygon, we built POS. We used Tendermint. We used Tendermint as one of the nodes in the Polygon POS network. So we worked with Tendermint extensively, and so it's good. But like when we were starting Avail, we had these two choices, and Substrate was written in Rust. Our whole stack is based in Rust. It's pretty modular, very easy to make changes. We can, suppress runtimes, change runtimes. Like, it's a lot easier to work with. It also gives us a lot of things out of the box, like grandpa babe consensus, for example, nominated proof of stake, Tendermint, or specifically Cosmos proof of stake, has this whole delegation centralization issues, and also we wanted a clear path to go from 1,000 validators right now to probably 10K or more later, and so Substrate has that very clearly. So we want to be a very decentralized sort of L1, and so those are where some of the parameters.
Feel free to challenge him, like upstairs. And we have the topic
Thank you.
of proofs again.